So, good morning. Welcome to the tooling session on the last day of the QDev days. So we have this morning 3 talks about Qt Creator, various aspects. And yeah, we'll start with the first talk about targeting mobile platforms, and not only one of them, but multiple. And please welcome Aurindam Jana to this hopefully interesting talk.
Thanks, Cornelius. So welcome to the session on targeting multiple mobile platforms with Qt Creator. What we are going to talk about is not just the Qt Creator aspect, but also what you need to consider when you are creating a cross-platform application, specifically for mobile phones or smaller devices. So hope you guys are not hangovered yet. Was the party good yesterday? Bro? Cool. So a little about me. My name is Aurindam Jana. My RSC handle is Ori __. You can contact me at #Qt and #QtCreator on Freenode. Some of the things I have been developing Qt since, or working on Qt since quite a long time. I work in the Berlin team over here in QML tooling. We do Qt Creator, installer framework, all the tooling around Qt. I specifically was doing and still doing debugger profiler for QML. In my spare time, I also code for iOS. And so what is my target audience over here? That my target audience are people who are migrating from desktop application to mobile platforms, or who have their applications right now running on, or the application running on different mobile platforms and want to have a cross-platform solution. So quick question, how many of you are desktop developers? Oh, quite a bit. And how many of you are mobile developers? Okay, that's pretty much it. So then it should be, let's get going. So my agenda is basically a 2-part agenda. First, I talk about strategies that you need to focus on if you are targeting mobile platforms. So what are the things that you need to consider, which is because the desktop and the mobile world, they're quite different. And then I talk about how you can develop and deploy using Qt Creator. How do you set up a development environment, basically. And you can ask questions in between if you have questions. And if we have time at the end, we'll also take questions at the end. So first, strategies to target multiple mobile platforms with Qt. So the advantage with Qt is that we can, with a single code base, it's typically a single code base, you can target all your desktop platforms and, of course, mobile platforms. Lars has already talked about iOS and Android for 5.1. Blackberry is already supported. Sailfish is using 5.1, or at least current Qt Creator Qt 5 for their platform. There is a community effort on Tizen, and I think Lars already mentioned that we are doing something on WinRT, and which would be out with 5.3. So that pretty much is almost all the mobile platforms that, or the major mobile platforms that we have right now, or in the near future. Yes.
Is WinRT and Windows Phone, is that the same? That will include.
Yes. So what is Qt good for? Qt is glorious. What are the advantages with Qt? You have, of course, faster development time because you have a shorter learning curve. You do not need to learn each platform-specific languages. So if you see all the 3 major platforms, nothing is common. You need to either learn Java, Objective-C, or C#. Nothing in common. With Qt, that pretty much solves it. Since most of you are desktop developers, you just can start using your Qt knowledge and start developing for mobile phones. The other thing is you have a common code base, which means that maintenance is easy, and we have a comprehensive cross-platform tools for Qt, which makes your debugging and profiling and other analysis also pretty much easy. We use native, so we are not, of course, not an HTML. We are not based on HTML, or we do not have an HTML5 layer for some of our competitors in the mobile space have cross-platform, which is based on HTML5. We use native, so you get high performance, which also translates the basically, since you have a single code base and a single team, it translates to smaller and cohesive teams rather than having a separate team for targeting Android, a separate team for targeting iOS, and a separate team targeting Windows. And in the end, you have, of course, a higher return of investment and faster time to market. But of course, Qt is not a magician. Qt is a tool set. It provides you the right tools to do it, and you need to use it properly. Otherwise, if you expect that you write a Qt program and it will work properly out of the box for each mobile platform, then you're in for a little surprise. So what is essential is that you need to understand what are the limitations and how do you find out ways, or what are the solutions to work around it. So let's go to the first thing that we have. What should your application architecture look like? 2 years ago, there was an X-Troll called Girish Ramakrishnan. He talked about QML, and in his talk, he talks about the application architecture that he typically would see or like to see in a Qt QML application. He, based on his experience with Qt Multimedia Hub, and this is something from that presentation. This is something very important. You have to realize that your QML application should have a UI presentation layer and backend, so basically the model view controller. However, what is important is that the view should be in QML and everything else should be in C++. That arrow over there points only in one direction. So, and that is important. If you have an application that does it the other way around, or if you have a double-headed arrow, you're most probably doing it wrong. QML should be aware of C++, not the other way around. There are reasons for it. So first reason is that if you do it the other way around, QML, you can pretty much go into spaghetti code. Keeping the model and the controller in C++ enables you to have unit test cases. You can use the Qtest framework and write unit tests for basically testing your backend. And the advantage of having just the UI in QML, you can just move the UI for a particular mobile platform and have another UI. So that's pretty much a very, let's say, only a fraction of the effort that you would have to do if you start having mixing up your model view controllers. There was somebody had also asked, why should we not have the model in JavaScript? Well, it's for me. Although I have been developing C++, I'm also kind of consider myself a JavaScript developer. But honestly, I see Qtest framework as a very good testing framework, and there are no equivalent test frameworks for JavaScript. There's I think JScript or something, but anyway, so it's much more easier to test it. That's my personal view, and I think given the fact that the way that JavaScript works in QML, it's better that you have it in C++. So you're not basically dependent on a JavaScript engine at all. Any questions? Okay, so how does that help us? First important thing, that when I was writing my application, first for Harmattan, and then when I ported it to Android, I had problems. I had problems with the screen sizes. I had problems that Android has 4 different resolutions. I had problems with the font. I had problems with border images. And then later on, when I tried to port that same application to Blackberry, I encountered the same problem. So then I thought that so the first time that I did my porting from Harmattan to Android, I had just what I did was I had just changed the image. So if there was an image, I would just say it, okay, _Android, pick that image up for a particular resource. But of course, it doesn't scale up. So then I hit upon this idea of having a resource loader, and I implement the resource loader in C++. So what it would typically do is the C++ engine, when the application starts up, it queries the device, it queries what resolution is supported, what is the screen size, and the resource loader and the QML code basically asks the resource loader to give me the resource. So it would typically say, give me the button image, and the resource loader would know which of the many button images should it give. So basically which resolution is correct for this particular device. The advantage is that if you have to support any more resolutions, you just need to modify that particular library. And for most devices, this is basically incremental, right? So once you deploy it to a particular, let's say you deploy it to a Chrome store, so you pretty much know which devices are handled, and if there is a further, if Android or somebody else specifies, okay, we have another version or another resolution, you could just add that and just bump up your version. So it's basically completely agnostic, and the way that I did was I instantiated the resource loader and put it into the QML context as in the global object space, and I would just query on that object. So that basically solves. The other thing with border images is you need to realize that 9 slices supported in Qt, which is a really good thing also in Android. I think in almost all platforms. I'm not sure about iOS. And this is pretty useful to especially in those cases where you have, let's say, a resolution which is not the exact resolution of the phone, but let's say nearby, and then you could do those calculations to find out how it scales up. So the basic learning that I got was I need not have all resolutions or images of all resolutions in my source code. I just did I basically have 3 of them, and then I scale up or scale down as percentages. Any questions? Another important thing is font. The native font is different on different systems. So if you are specifying a font, make sure that your font is legible or readable on your target device. Often it doesn't work out. A lot of times I've seen HTML5 applications, for example, they have this cool, really nice font which is rendered really good on the browser engine on desktop, and then when you have it on the phone, it looks pretty bad. It's almost impossible to read. Okay, so one of the important things is, of course, you have to take care of your screen sizes. So there's nothing that we can do about it, that Qt can do about it. The only way is to make sure that if your application, basically test your application against different devices and specify it. You have, especially in Android, it's quite difficult to say what's the screen what resources you'd require. So that's one thing that has to be taken care of by the app developer. Next is the native UI, the look and feel. So I have put in button slices first from Android. The second one is from BB10, and the third and fourth are from iOS 7 and iOS 6 respectively. They all look different, of course. That is what platforms care about, that they should have a different look and feel. So what's the best way to do it? I would suggest using styles. So what you would do is, very important in QML is make as many components as you can. So have a basic button component that does nothing apart from making sure that the button press is a button press, that when a mouse leaves that space, you get a signal when the mouse, or when a touch enters that space, you have a signal. Basically implementing basic functionality of a button. And then you would have these styles called Android style or BB10 style or iOS style that is applied on top of this basic button. So your work of porting significantly decreases, because the only thing that you need to take care of is the topmost layer. So all your components or a list view, everything should be down to its basic. Think about it as they are flat basic structures that should work any amount of styling or any additional features that is platform specific should be abstracted out, should be on the top layer. Questions?
Question about the styling. Is that what do I have to mimic the native style on an Android platform, or is there like a support in the creator voice? Like I remember from back then from the desktop styles, Mac styles, Windows styles.
So what we have in 5.2 or 5.3, what we'll be having is Qt Quick Controls. Right now it's for desktop. We'll also be having it for mobile, and we can use that for Android. So we have something like an Android style. However, for iOS, you would still need to create it. We cannot give you a default iOS look and feel because of legal reasons. In my experience as an iOS developer, even if you're creating a native iOS application, there you typically have a UI designer who creates these slices, so which has a very similar look and feel as to what iOS provides. So it is not an extra effort, or you basically reusing your current resources. You just ask them to have these slices. The only advantage is that you are using the slices in a Qt application rather than in a native application. But the idea is that you should be abstracting anything that has to do with styling completely onto the topmost layer. Everything else, basic functionality, should be in a different file. So the idea is to have more components because it doesn't hurt. It's only useful. So the important thing over here is to have. So if you see, you have just a single code base for the QML presentation layer over here and the C++ backend. The only thing that is different now is just the top layer. So that probably is around just the UI part, and that too there's a style part. So that's probably around 10% of your entire code base. So 90% of it is still common, which is pretty good, considering the fact that in the other case you would have to have 3 or 4 code bases, and you would have to maintain each of them. And plus, if you start adding features, then you would have to update every version of the code base. So that's quite a lot of work. Next, UI navigation. Every platform, unfortunately, has a different navigation paradigm. So the first one that we see over here is Android. So Android has a back button, and there is a navigation bar that also has a back. So what does the back button do? Anyone knows what does the back button do? So the back button is basically a historical back. So it remembers how you went in the application and goes to the previous, not to the previous, basically it's a history. It stores in chronological order, and it's a historical back. The other one on the navigation bar, that back is basically a navigation or a hierarchical back. So it remembers what is the stack, and then it pops one out. Which means that in your application, you have to remember 2 ways to transition screens. Then we have on the right hand side, on the topmost one is Blackberry, which is just a back. Can anyone guess what does that back do? It's just a navigation hierarchical back, so it basically pops out. Same thing with iOS. It's just a navigation hierarchical back. I think with Windows, they also have both of them, the historical back and the hierarchical back. I'm not really sure. I do not have a Windows phone, but I think that's what they do. So this means that you cannot have your application having a back button and think that it is going to work, and if you just publish it to a store, think that people are going to use it the way that you intended it to. So you should be aware of this. So a lot of people implement states in QML because QML provides something called states. Good enough. But the interesting part about those states is it's not a state machine. In QML states, you can literally go from one state to the other. There is no sort of a check done. whether, so in a state machine, basically think of a state chart where you go from state 1 to state 2 under certain condition, and you cannot go to state 3. However, in QML, you can jump from any state to any state, which means that this logic is broken. We cannot implement screen transitions in QML. So the best way to do it, or the suggested way to do it, is have a state machine in the C++ backend. There was a talk again 2 years back by Aspen from QtHacks, where he talks about his application and the problems that he faced. And this was one thing that a tip that I got from him. So what I did was I used a QState machine, the QState machine class. The advantage with that is that you automatically get the historical back. So there is an API that basically gives you the historical states, which means that implementing QState machine or using QState machine, I get the Android, both the Android back and navigation bar back, and I can reuse the same functionality in Blackberry and iOS. So very important to remember, do not use the states in QML. They are basically, I think, I would say they are a misnomer. They just set some properties of your QML object. They are not exact states because it does not mimic a state machine. Any questions? The next important thing that a lot of people forget is that each platform or each device is different. And expecting a single code base to work across different platforms can be challenging. The best way that you could, one of the ways that you could do is, of course, ifdef out certain modules which do not work on certain platforms, or you could divide your code into separate modules and have those libraries load up, or query for certain features and have those libraries load up only if the platform or device offers that functionality. For example, in low-end Android phones, if you think that your Beer app or your Whip app is going to work, it does not, because there is no gyroscope, which means it cannot know whether you did that motion or not, which means that your application is broken. So things that to do, query for features. Yes?
Is there a way to ask Qt on which platform I'm running?
There is a way to ask, yes. Typically, that would be provided by something called device, or basically that comes in Qt Mobility, and you would typically ask for a device and query the device name or device resolution. Of course, it's provided by the platform, and Qt does the abstraction. So the very important thing, query for features. Do not assume that every device has all the features that you need for your application to work. Another important thing is Bluetooth. And now, if you have a game that works across a Bluetooth connection, probably it will not work on an iOS device because it does not pair up with another non-iOS device. Limitations. Another thing is hardware keyboard. So many phones have now software keyboard that people forget that there used to be something called hardware keyboard. What does that imply? It implies that if you have a text edit, or if you have some sort of user input, and if the user presses the keypad, the hardware keypad, then one of those text fields should get focus. You should not expect that the user will first click on that text edit and then go to the hardware keyboard. The way that it works in software keyboard is that you typically click on text edit and then a virtual keyboard comes up, right? But with the hardware keyboard, that doesn't happen. So you need to do that focus. You need to have a certain way, depending on your application, what is the default field that should be focused if the user uses the hardware keyboard. Any questions? Okay. Yeah, the other thing that I wanted to mention over here is databases. If you have some certain database access, I would suggest that you see the performance, which is the best database that can be implemented for that particular platform. For me, I had certain problems with SQL databases on Android. I thought it was slower than what it was on Harmattan or even on Blackberry. That's my personal experience, but maybe it's my code that was wrong. But I would still suggest that you, if you have some data, if you are doing intensive database queries, just check the performance on each platform. Another thing that I found out was when I was doing it for Android was that I had a database that was packed in an .apk, and unfortunately, that did not work because I needed to copy my database to a user readable writable space before I could use it. So these are certain tips you might say, you might call them. Remember that if you have a file that needs to be readable, writable, you need to, once it's unpacked, you need to copy it from the .apk to another folder where you can, to basically a user readable writable space. Okay. So another thing that I do not have it over here because is you heard Tommy's talk on our new offering Engine.io. So another thing that I was talking to a couple of developers yesterday was how do they manage their backend services? And this is again not a unified solution on all platforms. So if you have your game application that stores some sort of data in that basically wants to share some sort of data, you would either use probably publish it on Facebook or maybe have your own server which it queries to and stores it in the backend. So with the Qt Mobile Edition, that is one advantage. Basically, you have a unified cloud that all your applications on various devices can access using the same APIs. So you can store your data in the backend and use the same APIs to access it. So that gives you a common access point for all these applications. Yeah. The last thing that I would like to talk about when you're writing cross-platform applications is code maintenance. The advantage with the common code base is that you just need to cross-compile your code base. So whenever you modify your code, try and do builds for every other platform. Smoke check builds always, rule of thumb. Do not hack on a particular platform and then start checking for the others. Things might break and you might be, yeah, things might break and it's just irritating. The other thing is that if you are doing some platform optimizations, which you would need to do, also test it on other platforms because platform optimizations on one platform may have a side effect on other platforms. And the best thing is I think CI is your best friend. Have contiguous integration or some sort of something implemented similar to that in your development cycle. So that ends our first part. Looking for questions? Yes? So the components that are the controls that are going to come are basically are basic controls like a button, a checkbox, or a scrollable list, or a scroll area. So these are basic components. They are not platform specific. They would have just the look and feel of how a scroll area should look like on Android, for example. Yes, yes. It is not the complete set. Definitely not. So my idea over here was that exactly what you said is that you need to hack. My suggestion is a list view is a list view in all platforms. It behaves the same way. And typically, if you notice, now every platform has, there's some guy, I think, a couple, 1.5, 2 years back, he implemented that pulley menu where you drop down and then it starts loading. So now every platform or almost all applications started using that similar thing. So you can have your own paradigm. The idea is that you should have the basics component working and then try stylizing on top. If you have something very platform specific, just write a separate code. Do not even think about this way. If it's not going to be reused, there's no point in abstracting it out. But things like button, list views, um, navigation bar, etc., they are reused in all platforms, and it would make sense to have it. For example, the navigation bar in Android uh, or in Blackberry, it's they have a back button on the left, so it's basically a button. A navigation bar looks the same. The size can be different on each of these platforms. The same thing on iOS. It's a navigation bar. It has the left and the right, two toolbar buttons or two navigation bar buttons.
More like on a pattern level, not necessarily in a single control.
Correct. If something is not available on a particular platform, there is no point in abstracting it out. Yes.
So there must be some differences if you develop for, let's say, an iPhone or BlackBerry or Android, because Android is also dedicated for, let's say, bigger applications or bigger screens where you can really have bigger menus.
Correct. So basically, what you're talking about is the difference in screen sizes between a tablet and a phone. For a tablet and the phone, the same code base is not going to work. And if you think that the native solution, native way provides a solution, it does not. If you have a list view in the phone, in an Android phone, the same list view takes up pretty much the whole space in a tablet form factor. So the way that usually I can only talk from my iOS background was what we used to do is we used to have different screens and different screen transitions for a tablet and that different for a smartphone. Just because in a tablet you have much more screen area, it just makes sense to use it. You do not want to show just one list view over there. You can do so many things. You can probably split it up and probably show content what each of these items in the list view does. So again, that comes back to the point where basically over here where you would, or rather let's say over here where you would have a UI presentation layer which is different. So think about tablet as a different screen size and the different, what you would typically do is in your state machine, you would, for a tablet, you would have a different state machine, the way that each screen goes, how the screen transition happens. And for a phone, you would have it different because phones normally have a very similar screen size, 4-inch or 5-inch. But then in a again, tablets are there are phablets which are coming to phone factor, so it gets really messy. The idea is, for me, the best way that I could go around it is having a state machine. It just simplifies things so much, and I can test it. It's unit testable, so I know that it works. At least I do not need to manually test it every time. Any other questions? Yes?
On the client side of the database, can you tell us about your experience with best database containers suited with which platform?
No, no. Basically, what I had was a SQLite database which I was using.
With iOS?
I did not do it on iOS. I used it on Hamatan, Android, and BlackBerry. So I do not know. But I would suggest that check the performance is my suggestion if you have intensive data queries. So next thing that we come to is to develop and deploy using Qt Creator. So some things why Qt Creator? Qt Creator is it's a really good IDE. Who thinks so? Ah, cool. So it provides you with an editor. So you have a C++, a QML, and a JavaScript editor. Also other editors like Python and OpenGL and GL editor and a lot other bin editor, etc. But yeah, you basically have a decent editor with syntax highlighting, and you have a designer, which as part of Qt Creator plugin. Then you have debugger support. You have analyzer tools, both for C++ as well as for QML. It has really good device support, and it has integrated help. And the last point is that it also integrates with your favorite SCM. So it's a pretty much a complete IDE, and I think it best fits in our use case. What I'm going to show you is to deploy it to a device. I'm using Qt version 5.1.1. Qt Creator is the latest Qt Creator from master. The reason I was using I did not use 2.8.1 was in Blackberry they changed the way that keys are signed. Are there any Blackberry guys or KDAB guys over here? No. Oh, okay. They changed the way that Blackberry developer certificates are signed. So now they have just one unified way. And in 2.8.1, it used the older way. So I used Qt Creator 3.0, and I thought I could deploy it to a Blackberry device. But apparently, I compile in the morning, and I still cannot deploy it. It cannot detect the device. But it's master, so it's work in progress. So I'm sorry I cannot show you working it on my BlackBerry, but nevertheless, we can show it to you on Android. For iOS, Android, and BlackBerry, stock Qt Creator is good enough. The plugins are there in Qt project, so you just need to enable the plugins. If you're targeting Sailfish, it also uses Qt Creator, but the plugin is not there yet in Qt project. So you'd have to go to the Sailfish site and download the SDK. I have the SDK from the latest alpha, which is on Qt. They're using Qt 5 and that SDK. Yes.
I've seen that in some data, like I think it was Neo Mobile or it was in one attention, there isn't a designer in there. So I don't know how it's working with the Sailfish. Is there a design support?
The design support is in the Sailfish SDK. The quick design support is not there.
Yeah.
The reason is that they need to they need to export the Silica Sailfish components for the designer to recreate those components.
Yes. So retail information.
Yes, and the Sailfish Silica components are currently work in progress. They have not been published. So until and unless they are published, you cannot reuse them in Quick Designer.
Okay, so you think that as soon as they are going to publish them, there will be design support?
Yes. It's mainly because it would not make sense to, because once you have the meta information, it's equivalent to being published. You have it in your source files. So for setting up Android on stock Qt Creator, what do you need to do? You need to download the Android SDK. For Windows, you need to do an additional work. You need to install the Android debug bridge to enable USB debugging. And you need to do it from the manufacturer of the tablet that you have, because every tablet manufacturer would have a different device driver for Windows. Next, you need an Android NDK. The reason that you need an Android NDK is because we are compiling C++ code, native code, and without the NDK that would not be possible. You need Apache Ant version 1.8 or later. You need JDK or OpenJDK version 6 or later. And after you have installed all those, try and run the Android tool, update the SDK to whatever your phone supports or whichever SDK you are targeting. By default, I think it downloads the latest one, which is 4.3, if I'm correct. And this phone, I have, I think, 4.1 over here running. And configure Qt Creator. So how do you configure Qt Creator? This is Qt Creator. Go to Tools, Options. There is an Android tab here. What you need to do is put in your SDK NDK location path, and these two fields, the ANT location and JDK location, would be picked up automatically. In some cases, you might have to give the ANT location, but if JDK is in your path, it would pick it up automatically. So otherwise, just enter those fields. If you want to have a virtual device, use the Android Virtual Device Manager, add some devices, and this basically what it does is create kits. Is everybody clear about what kits are, or do I need to explain? Yeah? Anybody has confusion about kits? Yes? Okay, there's one hand. So kit is basically a, a set of tool chains, or basically a grouping of possible tool chains, debugger, etc., that you would need for a particular target. So let's see how kits look like. My colleague Tobias will give a talk on kits pretty soon. But this is how a kit would look like. You would name your kit as something foo, what it does basically. And then what are important is the compiler that you're going to use for that particular target, the debugger, and the Qt version. So it's basically a grouping of all this for a particular target. So if you check that, it automatically creates Android toolchains. So I would have Android toolchain over here, Qt version, there's Android ARMv7. These are the Android toolchains. Cool. So I'm going to show you shortly, once I show you how to set up for Blackberry. Next is for Blackberry. Blackberry is simpler. You just need to mention the NDK path. With the latest NDK, apparently you also need to run SDK install because it does not install the SDK. So if you download the native NDK from the Blackberry website, it just downloads Eclipse IDE. That's it. It does nothing else. So you need to run SDK install, which is in your in the root directory of the NDK, and install your latest version. I think it's 10.1 point something. And after that, if you require a simulator, you also need VM player to be installed on your machine. And configuring Qt Creator is pretty simple. Go to the Blackberry tab. As you see, it automatically detected, it's 10.2 right now, okay? It automatically detected my NDK, or you could just add the file browser, basically browse and add NDK. For development, you need some keys. This is something that you can get in the Blackberry, again in developer.blackberry.com. You need to register there, and you get a author key that you save in your home folder .rim under .rim, and this author p.p12 that you see. So once you're good, what you need to do is add devices. By default, the Android device is added in stock Qt Creator if you enable the Android plugin. For Blackberry, you would have to add a device, Blackberry device. It should have auto detected, but I think it's not working right now. But typically what you would do is add that. You would have a device password. It would have been added, and then if you see in the kit, right now there's a big red over there. Basically the device type is wrong. It should be a Blackberry device, and then I do not have a device right now, default device. It would, otherwise the default device would show up here. Okay, so let's quickly go to the next one. Setting up for iOS. Recently Fauzi, my colleague over there, just pushed the patches for iOS. So the good part is that Qt Creator also has iOS support now. what you need to do is install the latest Xcode, install iOS SDK, install the command line tools. Of course, get a developer license, otherwise it doesn't work. And configuring Qt Creator is simply adding the QMake, or basically adding the Qt version that the Qt that was built for iOS. Deployment works out of the box on master. Debugging does not. For debugging, what you would do is you would export a .xcode project, import that in Xcode, and then you debug your project. But Fauzi promised, or rather promised, hopefully promised, expects debugging support to be there in the final version of Qt Creator 3.0. For Sailfish, the way that compiling or building works is that you need a virtual machine because it does not have cross-compile toolchains. So you need VirtualBox. That's a hard dependency. You have to install a VirtualBox for your application to build, and rest is pretty much already set. If you download the Sailfish SDK, everything is configured. You just create a new project and you're good to go. So one thing that I had told about was that if you make any modification in your code, you should try to test it with other platforms. This is one good advantage with Qt Creator. So you have all these kits. So you probably would have an Android kit, a Blackberry kit, an iOS kit, and eventually a Sailfish or another platform kit. And then you have your same project, and if you build, and from the same IDE, you can build for different platforms at the same time. So you can always test your code, at least for smoke check builds, whether something breaks on your change breaks something else on another platform or not. So I hope I'm going to show you. This is an Android 4.1. Let's see if this works. So all I did was just specify my NDK and SDK and basically Apache AND path. Everything else was, the kit was automatically created. And then I just created a new project, build and deploy. That's about it. That's the maximum that I did for this. So while it's still deploying, let's see how the Sailfish thing works. Okay, something's happening. No. This is the Sailfish Qt Creator, the Qt Creator that is in the Sailfish SDK. They have an additional mode called SailfishOS, which over here you could configure your Sailfish targets. So right now we have a Mare toolchain, and your target would right now I think is SailfishOS. If you have multiple targets, you can add multiple targets over here. But right now in the repository, I think it's only just one. Everything is pretty much set up with by the SDK. There are two buttons over here. The first one starts the build engine. You need to start it up since the compilation is done in that virtual machine. And the other is for the simulator. I'm using the default template. Project is outside shared home. Okay, new file project. Blah blah. Let me put it in my home folder. Let's run it. You would see some different output over here. The reason is that what QMake over here does is calls RPM build, and you need a spec file. The idea over there was to unify the packaging and the building process so that when you are packaging your application, you do not miss out any particular file or any resource. So and it does an rsync after that. If I can see, that's the emulator. That's your application running, and this one loaded up. So that's a basic hello world application running on the Android. Cool. So let's get to our presentation. In summary, what you need to do is have think about a dedicated resource handler to handle different screen sizes, different resolutions, and different form factors. For example, a tablet, a phablet, or a phone. A suggestion is to keep styles in separate QML components, so that if you're targeting different look and feel, you just need to replace these files. Use a state machine for UI navigation, because the navigation paradigm in different platforms it's just different on different platforms. The fourth thing is that do not assume platform or device features. Query for features, and then query for features before you start your application, so that your application works as expected, or at least pops up a message that this application cannot be run on this phone because of this reason. The fifth thing, CI is your best friend. Whenever you change your code, build it against all other platforms. The next thing that we saw was the development environment setup, what you need to do in QtCreator, or what are the SDKs or NDKs that you need to install in order to target different platforms. And the last thing that we saw is build and deploy. So that almost ends my presentation.